Next. As we know that in the previous class, we have been stopped up to the question number 6. Now, in the today's class, we go with the question number 7. Dear students, here we should know about the next condition which is related to the 7th question. A body of length 1 meter having cross-section area 0.75 meters square. There is a solution for the 7th question. Solution for the 7th one. A body of length 1 meter. It means the cross-section area and lengths are given. This is equals to 1 meter and the cross-section area is 0.75 meters square. As the heat flows through the given material, that is 6000 joules per second, that is Q by T is equals to 6000 joules per second is the given value. Then find the temperature difference. Then find the temperature difference between the two ends of a given material. The given value, that is called a coefficient of thermal conductivity, K is equals to 200 joules per meter per Kelvin. That's all. Here, solution for this question, we know that there is a material is given. This material we call as a rod or something we consider, and it has a certain cross-section area. The area of cross-section is 0.75 meters square. The length is given. The length will be how much it is? 1 meter. The amount of heat energy flows from point A. So this is the point X to point Y. That is theta 1 and theta 2. That is called therefore temperature difference. Theta 1 difference theta 2. Or you can write delta theta is equals to question mark. This you have to calculate. The coefficient of thermal conductivity associated with this material is 200 joules per meter per Kelvin is given. Then we know that from the statement of coefficient of thermal conductivity, the rate at which the heat energy flows is always equals to that is directly proportional to the cross-section area and the temperature difference to the unit length is called as the thermal conductivity. Then, so this value is given. So this value is how much you have? 6000. So this is the given value. 6000 is equals to coefficient of thermal conductivity is 200. So cross-section area 0.75 into delta theta. This is the unknown value. We have to calculate this divided by the corresponding length is given 1 meter. Then you see here the 10 and this 0 will be cancelled, and here this 0 and this 0 will be cancelled. 2 ones are 2, 2 threes are 6, that is 30. And we have 30 is equals to 0.75 into delta theta. Delta theta is equals to 30 divided by 0.75 is equals to 30 divided by 0.75 is equals to 40 degrees Celsius. So if I divide this, you will get what? 40 degrees Celsius. You see which is the correct option from the given condition. Question number 7. You see the question number 7. The option number B is the correct answer. Hence, option B is the correct one. Option B is the correct. Next question here. A wall has two layers A and B made of different materials. Made of two different materials. The thickness of both layers is same. We have the two materials. Say for example, imagine. So this is the corresponding materials which has been taken from the given condition. Say this is the junction temperature. The junction temperature is given as what? As a T. It is also called interface. Interface is the connection between the two ends. Is called as a interface. Then you see, it is made with the different materials. These are going to be having different material. It is also made up of different, and this is also going to be having a different material. Then the thickness of both layers are same. The thickness of both the layers, the thickness which is going to be considered as L1, and this thickness will be considered as a L2. And hence, if both are equal, then we can write L1 is equals to L2 is equals to L. The thickness associated or the corresponding distance between the 2 points will be considered as the same. The next one. Here, the thermal conductivities of A. This is we call different material as A, and this will be called as B. The thermal conductivity associated with the A is given as Ka. This is called as a Ka, and this is called as a Kp. But condition is given as the condition is given. What is the condition we have? The coefficient of thermal conductivity of the first one is always equals to 3 times of the coefficient of thermal conductivity of B. Then here the condition temperature across the wall is 20 degrees Celsius. Across the wall is given as 20 degrees Celsius. In the thermal equilibrium, what is thermal equilibrium? Thermal equilibrium is the one in which maintaining the same amount of temperature or maintaining the two bodies at same temperature is called as a thermal equilibrium. We know the condition. So what the condition we have to mention? There is a, say for example, the temperature at this point, at the point A initially we called as a X, and here the temperature maybe rises to, it rose to up to how much it is? X plus 20 times of the given value. X plus 20 times of the given value. Hence, we know the given condition of thermal conductivity. From the equation, there is a what you have. This is Ka, coefficient of thermal conductivity of the first one, Ka into cross section area into. So this will be having the given condition. You read the question carefully. Then what is the final temperature? You have junction temperature. This is the junction temperature. I will write this one as a capital T minus Ex. This is final minus initial divided by how much is the corresponding thickness you have? L is equals to. Then go for the second one, because this is dq divided by d into t times of this is A is always equals to dq divided by dt times of the second, that is B, Using this formula here, the rate at which the heat energy flows from the first system to the second system, both are maintaining the same temperature. Same temperature is nothing but what? The amount of heat current flows. So this is also called as what? Heat current due to HA is always equals to HB. This is called as a heat current. Heat current. It can be written as H. Similarly, so for this is KB into cross section area. The area of cross section of the first one and the area of cross section of the second one will be same. Then here the temperature will be X plus 20 minus T whole divided by L, because the temperature final, see final minus initial for the second phase. This is the first phase and this is the second phase. This is the interface. For this it will become what? T minus X. For this is final minus initial. Therefore, now you simplify for the given condition. What you get here? Once you simplify for this, you may get the length of this and the length will be cancelled. Then once the length will be cancelled, cross section area from LHS and cross section area from RHS will be cancelled. Ka, keep it as it is. Ka, coefficient of thermal conductivity of the first one. If it's going to be, keep it as it is. Then into T minus X is equals to K times of B into X plus 20 minus T. Then you simplify this. Ka, given condition, Ka is equals to 3 times of Kb. This is 3 times of Kb into T minus X is equals to Kb into X plus 20 minus T, where Kb and this Kb will be cancelled because coefficient of thermal conductivity from LHS and RHS will be cancelled. Then take this 3 into the bracket. What you get? 3 times of T minus X is equals to X plus 20 minus T. Then 3 times of T. This is called 3T minus 3X is equals to. This is X plus 20 minus T. Then you get there is a condition minus T from RHS. It will be called as plus. So this is 3 times of T plus capital T minus 3x minus x is equals to 20. Then 3t, and you see this is x, similar terms. This is 4t minus 4 times of x is equals to 20. Then taking 4 common, t minus x equals to 20. T minus x equals to 20 divided by 4. 4 ones are 4 5s are. Temperature difference at the junction is 5 degrees Celsius. Now you see the option. Which is the option? The option number, the temperature difference across the 2 points. So the temperature difference between the 2 points. It means option number. Option B is the correct one. Option B is the correct one. So we go with the next one here. Question: a metal rod of length 2 meter has a cross section of 2A and A, as shown in the figure. The question is going to be shown with the help of the given diagram. So here is the question. The length is given for this is L1 is equals to 1 meter. Similarly for the second one, L2 is equals to 1 meter. And the cross section area of the first one is given as 2A, and this cross section is given as A. The temperature is maintained at this end is 100 degrees Celsius, and the temperature at the other end is 70 degrees Celsius. And now this is C is called as a junction point. Now, the ends are maintained at a temperature of 100 degrees Celsius and 70 degrees Celsius. The temperature at the middle point is, we have to calculate the temperature at the midpoint. The temperature at the midpoint. Say this is theta 1 and say this is theta, and this is we call as a theta 2. This is initial temperature. This is the corresponding junction temperature. This is we call as a final temperature. Therefore, we know that from the statement of thermal conductivity, the corresponding the Q by T is also written as, it is heat current. It is also written as, that is we call as a dQ by dt. You can consider any one. So this is we call as the rate at which the heat amount energy will be flows. This is called heat current. This is the small change of the heat current. So you can write any one. Now I will go with the similar equation. Now we can write here, this is K1. I will write this one as the coefficient of thermal conductivity because it is made with the similar material. Say this is K1 A1 into, this is theta 1 minus theta whole divided by L1 is equals to, this is K2 A2 into theta minus theta 2 whole divided by L2. Therefore, K1, so here we know that K1 is always equals to K2 because same materials are using. Same material, for the same material coefficient of thermal conductivity will remain same. It means K1 is also equals to K2 is equals to be considered as a K. It means from the given condition K1 and K2 will be cancelled. Then length is given. How much the length? 2 meter length. Total we are given as a 2 meter it is. So 2 meter length is given and divided for equally for the both ends will be 1 meters. Then A1 is given. How much even? It's a 2 times of cross section area. Theta 1 is 100 degrees Celsius minus junction temperature as a theta is equals to A2 is equals to how much is given? A2 will be A into junction temperature, keep it as it is, minus theta 2 will be 70 degrees Celsius. This is 70 degrees Celsius. The cross section area from this end and cross section area from this end will be cancelled. Therefore, you will get this is 2 into 100 minus theta is equals to theta minus 70 degrees Celsius. This is 100 degree. Then multiply. We get this is 200 times. This is 200 minus 2 theta is equals to, this is theta minus 70. So here we have theta term. Here you have theta and here is also we have theta. And make it one side. Remaining numerical terms we make it one side over there. 200 plus 70 is equals to theta plus 2 theta. This is 270. 270 is equals to 3 theta. Theta is equals to 270 divided by 3. 3 ones are 3 nines are 27. So therefore, theta is equals to 90 degree. It means from the given question, so this is 90 degree Celsius. Option number 3 is the correct one. Option number 3 is the correct. In the next question you have, which of the following circular rods? Which of the following circular rods? We have a circular rods over like this. So this is we call as a circular rod. Okay. So this is the circular rod. Given that R is the radius and L is the length. So this is we call as the, imagine this is the corresponding circular rod, and here this point O is called as what? And a point. So here from this to this end is called as a radius, and this point 2 times of the radius is called as what? And a diameter. So therefore, now 2 times of the radius is called as the diameter. The given condition is what? The corresponding radius of the given circular rod is R, and the length is given. The length will be how much is given? L. The length will be L. Each made of same material. Each will be made with what? Same material. It means whose coefficient of thermal conductivity K is same. The thermal conductivity will be same, whose ends are maintained at the same temperature. Ends also maintained at the same temperature. Ends also maintained at the same temperature. It means they are in thermal equilibrium. They are in thermal equilibrium. Thermal equilibrium. Maintaining the same temperature, that is nothing but what? It gains the thermal equilibrium. Then will conduct the most heat. Which will conduct the most heat? We know that from the statement of the coefficient of thermal conductivity, Q by T is going to be directly proportional to, Q by T is directly proportional to cross section area. It is directly proportional to cross section area, directly proportional to temperature difference between the two ends, and inversely proportional to the thickness or the separation distance between the two faces. Separation distance between the two faces, or it is also called as a thickness. Now you see from this given condition, Q by T is directly proportional to cross section area for the circle. Area is given as, area is equals to pi r square. We will write this one as a pi r square into delta theta divided by length. Then you see pi is constant. Temperature difference is also constant. Which is the greatest value which will allow the amount of heat energy to flow? Here R square and L is the only variable. Then you see Q by T is directly proportional to R square divided by L. If amount of heat energy, this is also called as a heat current. Heat current is directly proportional to R square, inversely proportional to L. Then you see increase in the radius, double the radius, increase the radius, amount of heat energy flows also goes on increases. Decrease the length. If length goes on decreases, you see it goes on decreases. See then, if it decreases, this will be increase. So this will be condition. Now you see the question. R is equals to 2 times of R naught. R is equals to 2 times of R naught. It means where length will decrease, where L is equals to initial length, they are talking about that. So similar, by using this relation, you can come to know that option number 2 is the right answer. Option number 2 is the correct one. Here we go with the next question. In the question number 11, heat travels through the vacuum. We know that heat travels through the vacuum. The first option you see conduction. So conduction means what? The amount of heat energy flows with the actual movement of particles of the medium. So there is an heat will flow due to actual movement of particles of medium. It means there is a need of medium for the transmission of a heat will be takes place is called as a conduction. The example for the conduction is what? Heating a metal rod. Metal rod. Heating a metal rod is the best example for the conduction. It means here the question is what? Heat travels through the vacuum. Convection is nothing but what? So convection is nothing but what? The amount of heat energy will flow due to there is an actual movement of the particles of the medium is called as what? Convection. Example for this is boiling of a water. Boiling of water is the best example for convection. How it is? Imagine there is a small container is going to be placed on the wire gauge with the help of a Bunsen burner. If I am going to be heat this with the help of a Bunsen burner, we are going to be heat this water. There is a small bubbles are going to be arises. They are moving from bottom to top. It is, see, they are moving like this. So because the hot water molecules will going to be having lesser the density decreases, hence they are going to move towards the surface. Cold molecules will have the heavy density, hence they are going to be readjust their position. Due to that, it means there is an actual movement will be takes place for the transmission of a heat energy. So this is we call as a convection. Then third one, heat travels through the vacuum by the remaining one process is nothing but what? That is called radiation. So our answer is what we call radiation is the right answer, because radiation is the process in which the heat energy will flow from one end to the another end without any need of material medium, because these radiations are called as what? Electromagnetic in nature. So hence there does not require any material medium. Why? Because they shows a transversal nature. They are in transversal. Why they are transversal? Because they travel perpendicular to the direction of a propagation. That's why. So the radiations does not require any medium. Next question. The Earth radiates the infrared region of the spectrum. The spectrum is correctly given by the radiation infrared which is emitted by. So it means, of course, there is the Planck's law of radiation is the one which going to be explains about the amount of energy which is radiated from the sun's atmosphere to the Earth. The answer is what? Planck's law of radiation. Planck's law of radiation is the right answer. Planck's law of radiation. Question number 12 is the Planck's law. Infrared radiation is detected by. Infrared radiations always detected by using an instrument that is called pyrometer. Infrared radiations always used to, and they are going to be used to detected by using an instrument called as pyrometer. Pick out the statement which is not true. IR radiations are used for long distance photography. Of course, infrared radiations, they are 100% used for to carry or to capture the long distance photography. The first option is the correct one. Then IR radiations are detected by using a bolometer. Of course, bolometer is a device used to detect the infrared radiation. Sun is the natural source of infrared radiation. Yes, because atmosphere, sun is going to be consisting the different types of radiations, and then among them, it is the one of the radiation that sun's atmosphere consisting the infrared radiations. Infrared radiation arises due to inner electron transition in atoms. Thus, this is the wrong answer. It is the wrong answer. Question number 14, we have IR radiations are not arises due to the electron transition in atoms. So option number B is the correct answer for us. Okay. Next, a hot, a hot and cold body are kept in a hot body. A hot body and a cold body are kept in vacuum, separated from each other. Which of the following cause the decrease in the temperature of a hot body? We know that. So this is quite simple. Will happen in everybody's in going to be seen this. So we are going to be justifying. So this is the one cup of tea which is going to be having a hot cup of tea here. Imagine. So there is a temperature, if I measure this, is about more than 80 degrees Celsius. And around this, if I going to be kept a cold tea here, if I going to be place a cold tea over here, the temperature, if I measure this, it's almost about a room temperature. So this room temperature, say about in Kalburgi or in somewhere, you can just almost you can just find out it's about nowadays it is about 28 degrees Celsius at room temperature. Now the temperature will going to be automatically decreases and it will maintain it automatically. Which process will they happen here? So this is only maintains the normal temperature. It's because of what? And a radiation process. It's only because of radiation, not any process. Because if I touch together, there is an actual movement will be takes place. If I going to be pour from one cup to the another cup, actual movement will be takes place. If I boil this, again there is a convection will be takes place without any actual movement. With actual movement, both will be takes place. One conduction process will be takes place, another is convection process will be takes place. To avoid this, if I place side by side, and atmospheric particle will going to be maintains the common temperature, and hence due to radiation is the process in which there is a temperature of the body goes on decreases. Okay. As in the morning session, there is going to be a doubt has been asked over there about the question number 19 and 20. So you see there, a black body radiates, question number 20. It's so important. Solution for the 20th question. A black body radiates the energy at the rate of E watt per meter square at a high temperature of T Kelvin, when the temperature is reduced to half of the given value of temperature Kelvin, and the radiant energy will be, we know that the amount of heat energy transmitted, that is E, is directly proportional to fourth power of the absolute temperature. Therefore, E1 is equal to constant, say this is K into T1 to the power 4, say equation number 1. Similarly, E2 is equals to K into T2 to the power 4, say equation number 2. Then dividing equation 1 by 2, we get E1 by E2 is equals to, this is K1, so this is this K into T1, K divided by K, T1 by T2 whole to the power 4, K and K will be cancelled. So this is E1 by E2 is equals to, this is T1. So T1 is given as how much it is? T. And T2 is half of the given value. So this is T by 2. T by 2 whole to the power 4. Therefore, now you simplify this equation. This is E1 by E2. E1 by E2 is equals to T to the power 4 whole divided by T to the power 4 whole divided by 2 to the power 4. 2 to the power 4 goes to numerator. Therefore, E1 by E2 is equals to, this is T to the power 4 by T to the power 4 into 2 to the power 4, T to the power 4, and this will be cancelled. So this is E1 is equals to E, and we have to find out E2 is equals to question mark, make a cross multiply. E divided by 2 to the power 4 is equals to, this is we got E2, then 2 into 2 is equals to 2 2s are 4, 4 2s are 8, 8 2s are 16. So this is E by 16 times, this is the given answer. Option number first is the correct answer. So first option is the correct one. In the next question you have, question number 19, the rate of radiation of a black body at 0 degrees Celsius is E times of joules per second. The rate of radiation of this black body at 273 degrees Celsius will be. We know that the given condition has been mentioned so clearly, that is we have E is directly proportional to T to the power 4. Therefore, E1 by E2 is equals to, this is T1 by T2 whole to the power 4. This is called absolute temperature. That is, absolute temperature is a T plus 273. Absolute temperature is given as T plus 273 times of Kelvin. So this is called as absolute temperature. Therefore, now E1 by E2 is equals to, the initial temperature for this is 273 plus 0 Kelvin whole divided by the final value 273 plus 273 times of given answer will be in Kelvin. Therefore, now here E1 by E2 is equals to 273 divided by, this is 273 plus 273. Add this, you will get 273 plus 273 is equals to 546. We got there is an 546. Then E1 by E2 is equals to 273 divided by 546. Then divide this, you will get the answer will be you will get 16 times of E you will get. So make a cross multiply because we need what E2. We need E2 value. Then make a cross multiplication. 546 divided by 273 times of E1 is equals to E2. Therefore, 546 by 273, you will get 16 times of E1 is equals to E2. The option number, you'll get option number first one. In this question, So there is a question number 17. Here we have the wavelength of maximum emitted energy of a body is given as 700 Kelvin. So it means T1 is given. T1 is 700 Kelvin. And the wavelength associated is what? Lambda 1 is equals to 4.08 micrometer. If the temperature of the body rises to T2 is equals to 1400 Kelvin, we have to find out the final wavelength, that is lambda 2. Then we know that the absolute temperature is inversely proportional to wavelength. Make a cross multiply. We get, so this is T lambda is equals to, say this is constant. Therefore, T1 lambda 1 for the first one, T2 lambda 2 for the second condition. Then divide this. We get T1 by T2 is equals to lambda 2 by lambda 1. T1 is given 700 Kelvin. This is 700 Kelvin divided by T2 is given 1400 Kelvin. So this is 1400 Kelvin. Kelvin cancel. Two zeros will be cancelled. 7 ones are 7 twos are 14. Then lambda 2 is given. Lambda 2 is how much you have? So lambda 2 keep it as it is. That is lambda 2. Lambda 1 will be given 4.08 micrometer. 1 by 2 is equals to lambda 2 divided by 4.08 micrometer. 2 ones are 2, 2 twos are 4.0, 2 fours are 8. Then this is 1 is equals to lambda 2 divided by 2.04 micrometer. Making cross multiply. Lambda 2 is equals to 2.04 micrometer.